So we continue with probability question number 14. Okay, we see question number 14. This is a question based on cards. So the question based on cards will require some explanation. Okay, you can note down this. See, when you consider a packet of cards, it's always a packet of 52 cards. And this 52 cards have four varieties in it. Okay, there are four varieties in it. So the first variety, we call it as hearts. Okay, the shape of a heart is there. Okay, and this is actually red in color. Okay, then we have the diamonds. Diamonds is, like a kite, like this. And this is also red in color. So we have 13 hearts and 13 diamonds. So in total, we have 26 red cards. Then we have clubs. Okay, clubs is like a flower. Like this, we have clubs, and this is black. And then we have spades, which is like a leaf. Okay, spades. And this is also black. So we have 13 clubs, 13 spades. The 26 cards here are black and 26 are red. So out of 52, 26 are red cards and 26 are black cards. Joker is not included. Sometimes Joker is also there in that packet, but for our calculation purpose, we are not counting the Joker. We are considering only these 13 cards each. Now, what are these 13 cards? The first card is not number one. Okay, it is called ace. So A is written there. Then we have 2, 3, 4, 5, 6, 7, 8, 9, and 10. These are called the numbered cards. These are called the numbered cards. And then we don't have 11, 12, 13. We have Jack, Queen, and King. Jack, Queen, and King. And these three are called the face cards. Why is it called face cards? Because there is a face on it. In some books, they have wrongly given ace as a face card. Please remember, ace is not a face card. Ace comes under numbered cards. Although number one is not written there, it is coming under numbered cards, not under face cards, because ace doesn't have a face, although it has a picture, but it is not a face card. In Jack, Queen, and King, you will find faces. So we have three face cards of each. Three face cards here, three face cards in diamonds, three in clubs, and three in spades. So we have 12 face cards. So if you are asked the question, what is the probability of getting a red card? So answer will be 26 upon 52. What is the probability of getting hearts? That will be 13 upon 52. We'll have to reduce to 1 by 4. What is the probability of getting clubs? Again, 13 by 52, 1 by 4. What is the probability of getting a black card? 26 by 52, 1 by 2. What is the probability of getting a face card? So 3, 3, 3, 3, 12 by 52. What is the probability of getting a red face card? Red face card will be 3 plus 3, 6 upon 52. What is the probability of getting a jack? So jack, 1, 2, 3, 4. There will be a jack in all the four. So 4 by 52. What is the probability of getting a red jack? That will be 2 by 52. What is the probability of getting jack of diamonds? That will be 1 upon 52. So a lot of questions on cards can be expected. So this is important that we know how to make this. And if you are playing some games with cards, all will be knowing it. If you have not played cards, then you need to know the variety of the cards, how much of each is there, because unless you know this cannot be solved. So in a well shuffled card, a packet of 52 cards, what is the probability of king of red color? So there are total 4 kings, out of which red will be 2. So it will be 2 by 52, 1 upon 26. Then the face card, how many face cards will be there? There will be total of 3 plus 3 plus 3 plus 3, 12 by 52. Red face card, half of that, 6 by 52, that's 3 by 20. Always reduce to lowest form. Jack of hearts, there is only one jack of hearts, that is 1 by 52. Spade, that will be 13 spades, 13 upon 52, that's 1 by 4. Then queen of diamonds, 1 by 52. Okay, so this is how we answer that question. Right. Then we have 5 cards, 10, jack, queen, king, and ace of diamonds are well shuffled. One card is picked at random. What is the probability? It is queen. So here the full packet is not there. Only 5 cards are there. 1, 2, 3, 4, and 5. What is the probability that it is queen? Queen will be 1 upon 5. Now, if the queen is drawn and put aside, now you are removing the queen. What is the probability that the card is an ace? Now there are only 4 cards left, out of which 1 card is ace. So 1 out of 4 is the probability. And what is the probability? It is a queen. Queen will not come because the queen was already taken out and removed. Now you cannot get another queen. So probability of getting a second queen will be 0. Okay, that's an impossible event. Coming to 16th now, 12 defective pens are accidentally mixed with 132 good ones. What is the probability of getting a good pen? So 132 good ones are there and 12 are defective. So total number of pens will be 132 plus 12, 144. So what is the probability that you are getting a good pen will be 132 upon 144. Cancel by 12, you get 11 upon 12. Next question, a lot of 20 bulbs contains 4 defective ones. So out of the 24 are defective. That means 16 are good. What is the probability of getting a defective bulb? So this is easy. There are 4 defective out of 20. So 4 by 20, answer is 1 by 5. Now look at the second part carefully. Suppose the bulb drawn in the first part is not defective. That means you are taking out a good bulb and is not replaced. You remove one bulb from 20. What is left? 19. Okay. And the removed bulb is a good bulb. So the 4 defective are still there. So out of 19, 4 are defective. That means 15 are good. Now what is the probability that the bulb is not defective? That means you have to find the probability of good one. So 4 are defective out of 19 still because the good bulb out of 20 was removed. So out of the 19, 4 are defective, 15 are non-defective. So probability of getting a non-defective will be 15 upon 19, right? Then question number 18. A box contains 90 discs numbered from 1 to 90. Find the probability of getting a 2-digit number. Now 2-digit number is 10, 11, 12, 13, 14 up to 90, right? So it's difficult to count that, but it's easy to count the single digit numbers. How many single digit numbers will be there? 1, 2, 3, 4, 5, 6, 7, 8 and 9. 9 digits. So out of 90, you have 9 digits which are single numbers. So how many double digit numbers will be there? 90 minus 9, 81. So 81 numbers are double digit numbers. Are you getting my point? There are total 90 numbers, out of which 9 are single digit numbers. So the remaining 81 will be double digit numbers. So 81 and what are the total numbers? 90. So probability of getting a double digit number will be 81 upon 90. That is cancelling by 9, 9 upon 10. Perfect square numbers. What are perfect square numbers? Number multiplied by itself and you can take out the square root of that number, isn't it? Perfect squares. So 1 square is 1, 2 square 4, 3 square is 9, 4 square 16, 5 square 25, 6 square 36, 7 square 49, 8 square 64, 9 square 81. 10 square is 100, that is more than 90, you can't take that. So you need to find the perfect squares from 1 to 90. How many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 perfect squares. So 9 out of 90. So answer will come 1 out of 10. What is the probability that the number will be divisible by 5? So what are the numbers divisible by 5, 10, 15, 20, 25, 30, 35, 40 up to 90? How many numbers will be there? There will be 18 numbers. Okay, so probability of getting a number divisible by 5 will be 18 upon 90. That will be 1 upon 5. Let's move on to question number 19. A child has a die whose face is shown in the letter. So your A, B, C, D, E and another A is repeating twice. What is the probability that you will get A? Now A has got, there are 2 A's. So probability of getting an A will be more as compared to the other alphabets. So probability will be 2 out of 6. That is 1 by 3. And what is the probability of getting D? Probability of getting D will be 1 out of 6. Next one, suppose you drop a die at random on the rectangular region. Now this is a rectangle. What is the probability that it will land in the circle? So this area is favorable to you, whereas this is the total. So what is favorable? That is pi r square. And what is the total? L into B. So area of circle by area of the probability of the event will be pi r square divided by L into B. So 22 by 7 into what is the radius? The diameter is 1. So radius is going to be half. So 1 by 2 into 1 by 2. So when you calculate this, you will get 11 by 14. And what will be the total? Total is L into B. Length into breadth, because this is a rectangle. So 3 into 2, we get 6. So 11 by 14 divided by 6. So 11 by 14 divided by 6. will be 11 by 14 into 1 by 6. So we get 11 upon 84. So this is how we find the probability that it will land. Okay, moving further to question number 21. A lot contains 144 ball pens, out of which 20 are defective. So out of these 144, 20 are defective. That means 124 are good ones, right? Noori will buy a pen if it is good. And if it is not buy, if she will not buy if it is defective. Obviously, you will buy a good pen only, not a defective one. The shopkeeper draws one pen at random. What is the probability that she will buy it? So she is going to buy a good pen. That means they are asking what is the probability of a good pen. So how many good pens are there? 20 were defective. So 124 are good. So probability will be 124 by 144. We can cancel by 4. We get 31 by 36. And what is the probability that she will not buy? She will not buy these 20 defective pens. So 20 out of 144. She will not buy these. So probability will be 20 by 144. Again cancel by 4. We get 5 by 6. Okay, refer to example 13 and complete the following. Now this is a question of 2 dice. Now this is very important that we understand this. Whenever 2 dice are thrown. See, single dice, when you throw, you will get 6 outcomes. When 2 dice are thrown, there will be 36 outcomes. Now, whenever there is a question of 2 dice, please make it a point to write down the outcomes, because this can come as a 3-mark question. Okay, so when 2 dice are thrown, what can happen? Both dice can show 1 each. One can show 1, the other can show 2. So we will have all these possible outcomes. The first dice is always showing 1, the other keeps on changing. First dice can show 2, 1, and then second one can show 1, then 2, 2, both can show same. Like this, I'm going to complete this table first for the 36 outcomes. So I can repeat this: 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6. I'll go on with the 4, 1, 4, 2, 4, 3, 4, 4, okay, 4, 5, 4, 5, 4, 6. Then we have 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, and 5, 6. Then 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, and 6, 6. So if you count this, the total number of outcomes is 36. Now, although it's not asked here, one favorite question is, what is the probability of getting a doublet? Now, always remember what is a doublet. Doublet is when both the dice show same numbers. When both the dice show same numbers, that means the first dice is also showing the 1, second is also showing 1. First is showing 2, second is also showing 2. So when both are showing the same numbers on the dice, then that is called a doublet. So how many doublets do we have? 1, 2, 3, 4, 5, and 6. So probability of getting a doublet is 6 by 36. That is 1 by 6. Okay, so this can come in the exam. Now, one thing that you have to observe, if you look at the total of the dice here, 1 plus 1 is 2. So there is only one case where you get a total of 2. If you look here, 2, 1 and 1, 2, this is also total of 3. This is also total of 3. So if you are asked a question, what is the probability of getting a sum of 3 or a total of 3 on throwing 2 dice? So how many cases are there? 1, 2. So you'll have 2 cases here when the total is 3. Okay, this we are calculating the sum. So how many cases? 2. So this is called a relationship, diagonal relationship exists. So if you don't have to look into the entire table. If you look at this now relation, what is the total of the dice? 3 plus 1, 4, 2 plus 2, 4, 1 plus 3, 4. So all this. So what is the probability of getting a total of 4 when you throw 2 dice? The answer will be 1, 2, 3. 3 favorable cases of total 4. 3 out of 36, that's 1 by 12. So I can go on with this. This will give me a total of 5. This line will give me a total of 6. This line will give me a total of 7. This line will give me a total of 8. This line will give me a total of 9. See, all of them are totaling up to 9. This line, I'm going to get a total of 10. 6, 5, and 5, 6, both are totaling up to 11. And there is one case, 6 and 6, which gives me 12. So what is the probability you will get 13? Impossible. What is the probability that you're going to get a total of 12? Only one case, 6, 6. You don't have to look everywhere. What is the probability that you will get 8? you have to look into this. 1, 2, 3, 4, 5 cases where the total is 8, 5 out of 36. So using this diagonal relationship, I can easily fill this, right? So what is the probability of getting a total of 2? We saw total of 2 only one case, that is why they have written 1 upon 36. This is 1 by 30. Now what is the probability of getting 3? So what is the probability of getting a total of 3? How many cases are there? 1 plus 1, 2 cases are there. So I'm going to write here 2 out of 36. Or I can cut this and write 1 by 18. Okay. Now if you look at 4, now see 4 here. What happens to the 4? What happens to 4? Now here in the board we saw 4, total is 4. How many cases? 1, 2, 3. There are 3 cases where the total is 4. So this will be 3 by 36. That is, you cancel 1 by 12. Similarly, you can do all this. This will come 4 by 36. This will come 5 by 36. This will come 6 by 36. Okay, you need to cancel all this. Then this is already given 5 by 36. Then this will come 4 by 36, 3 by 36, 2 by 36. And this is already given 1 by 36. So you can refer to the table and easily calculate this. And now this student is saying that there are how many outcomes? There are 11 outcomes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. There are 11 outcomes when we throw 2 dice. So do you agree that the probability of each is 1 by 11? Answer is false, because this is not an equally likely event. When you throw 1 dice, 1, 2, 3, 4, 5, 6, anything can come. It's an equally likely event. When you throw 2 dice, all the outcomes are not equal. You see, the total of 2, total of 3, total of 4, all are different cases. So if I say probability is 1 by 11 for everything, that is false. So you will have to say this statement is false because the total outcomes are 36 and it is not an equally likely event. Unless it's an equally likely event, for all outcomes, we cannot write the same answer, isn't it? Yes. And the previous video, you have seen what is the meaning of an equally likely event. So here they have calculated the probability. Argument is wrong as it's not an equally likely event. Okay, so a game consists of tossing a 1 rupee coin 3 times. So when you toss a 1 rupee coin 3 times, okay, when you are tossing one coin, remember heads or tails. When you toss 2 coins, what will happen? Either you will get heads, head tail, tail head, or tail tail. Now please remember, when you are having 2 games, some people think that head tail and tail head is same. No. Head tail means the first coin is showing head, second coin is showing tails, and in tail head means first coin is showing tails and second coin is showing head, so it is different. So 4 outcomes are there. When we have 3 coins, all can show heads, 1 head and 2 tails, okay, 2 heads and 1 tails, then head, tail head, all tails it can be, tail head tail, tail head, okay, 2, 4, 6, 7, one more case, THH. So all these are cases, 8 cases will exist when 3 coins are tossed. Here 4 cases will exist and here 2 cases will exist. So basically if you see there is a pattern, the number of outcomes are 2 when we throw a single coin. So here this is actually 2 square, this is 2 cube. So this is the outcomes and this is the number of coins. So if the outcomes is 2 and 2 coins are there, so I will get 4 outcomes. Okay. Here if the outcome is 2, this is for a single and there are 3 coins, then this will be 8. So you will have 8 outcomes when we throw 3 coins. So this is a question pertaining to 3 coins. So there will be 8 cases which I explained just now. What is the probability that Hanif will lose the game? Now, how is he winning? If he is winning, if it gives the same result, that means it will either give 3 heads and 3 tails. So that is how many cases are favoring him. Either he should get 3 heads or he should get 3 tails. So 2 are in favor of him. All the other 6 are he will lose. So what is the probability he will lose? 6 out of 8, that is 3 by 4, because he will win only in 2 cases. So 2 by 8 is the winning and 6 by 8 is the losing. Right? Okay, so we go ahead. This will be question number 24. Now a die is thrown twice. We can refer to the table that we made. What is the probability that 5 will not come up either time and 5 will come at least once? So if I refer the table which we had made, what is the probability that 5 will come? How many times is 5 coming? So if you look in the first line, only one time, 1. Second line once, 2. Third line once, 3. Fourth line once, 4. And fifth line, all are 5s, right? All are made up of 5. So up till here was 4. You have 5, 6, 7, 8, 9, 10. And last line also 1 case. So total cases where 5 will come is 11 out of 36. Right? How many cases are there in which 5 is there? 11. And therefore, what is the probability that 5 will not come? What is the probability that 5 will not come? So, how do we find that total there were 36? 5 has come at least once in 11 cases. So, the remaining, so if I subtract 36 minus 11, I'm going to get 25 cases out of 36 where 5 is not there at all. Okay, 5 is there only in 11 cases, at least once. And how many cases where 5 is not there at all? That is 25 by 36. So you are going to get probability that 5 is not there, 25 by 36, and probability that 5 is there at least once, that will be 11 upon 36. Okay, question number 25. That's the last question. Which of the following arguments are correct and which are not correct? If 2 coins are tossed, there are 3 outcomes, 2 heads, 2 tails, 1 of each, and therefore each outcome, the probability is 1 by 3. This I discussed with you just now, that when you are having 2 coins, the number of outcomes is not 3, the number of outcomes is 4. I hope you remember that. So I had discussed this, yes. So there are 4 outcomes, not 3 outcomes. So probability is not 1 by 3, that is wrong. This is false. Because when we throw, what is going to happen? We'll get 4 outcomes. So the question is false. Okay, probability of each outcome is 1 by 3 is false. Because there are 4 possible outcomes. Second part, if a die is thrown, there are 2 possible outcomes, an odd or even, therefore the probability of getting odd is 1 by 2. Okay. So what is the logical reasoning here that when you throw a dice, what will happen? You will get 1, 2, 3, 4, 5, 6. Right? Out of which how many are odd and how many are even? 3 are odd and 3 are even, right? 1, 3, 5 are odd, 2, 4, 6 is even. So what is the probability of getting an odd number? Will be 3 out of 6. So 3 out of 6 is 1 by 2. So this will be true. This will be true. So correct, because probability of odd number will be 3 upon 6, that is 1 by 2.